Okay, so for the 7-3 checkup, we're just going to go through each problem real quickly so you have a good idea of what's going on. Alright, so it says the first 4 problems to identify if the sequence is arithmetic, geometric, Fibonacci, or pyramidal. Alright, so when I look at the first one, if I were to write 10, 12.1, 14.2, 16.3, with decimals like this, it's a little different. So right away you know it can't be geometric. And if I take these two terms and add them up, would I get 14.2? No, so it's not Fibonacci and it's not pyramidal. So to check if it's geometric, right, do this. What is 12.1 minus 10? Right, you get 2.1. What is 14.2 minus, right, 12.1? It is 2.1. Therefore, each time we are adding 2.1, therefore this is arithmetic. Okay, next, when I look at this one, right away you go up 4, up 9, you know it's not arithmetic. If you multiply by 5, it's not geometric. So determine if it's Fibonacci or pyramidal, right? Well, if I add 1 and 5, do I get 14? No, so it can't be Fibonacci. So if I say this is 1 squared, right? This is 1 squared plus 2 squared, which gives me 5. This is going to be 5 plus 3 squared, which is 9, or plus 5, which is 14. Therefore, this is pyramidal. Remember, pyramidal is when you can add all these squares, and it gives you the next term. Now, this is not geometric. It's not arithmetic. All right, it's not pyramidal. And if I look, is 1 plus 2 going to give me 3? Yes. Is 2 plus 3 would be 5. Therefore, this is a Fibonacci. And the last one, I'm adding 3.5 here, so 3.5 plus 10.5 will not give me 15.75, so it's not arithmetic, right? It's really not Fibonacci and it's not pyramidal, so let's check to see if it's geometric. So let's take these two terms, we're going to take the new and divide it by the old, right? And when I take 10.5 and divide it by 7, I get 1.5. Now, if I take the next two terms, right, 10.5 and 15.75, I'm going to take the new divided by the old, and 15.75 divided by 10.5 gives me 1.5. Since these are common ratios, or I'm multiplying by the same number, 1.5 each time, that makes it geometric. Okay, next one. 650, so we're using arithmetic sequences here. $650 invested in an account at 3% simple interest per year. Write the first 5 terms of the sequence that shows the value of the account at yearly intervals. So right now, A sub 1 is 650, right? A sub 2 is going to be 650 plus, what is 3%? What is 3% of 650? Well, 0.03 times 650 gives me 19.5, right? So what I'm going to do here is now the second one is going to be 650 plus 19.5, which is going to give me 669.5. The third one then is going to be the 669.5 plus 3% of 650, which is 19.5, and this would give you $689. The fourth term, right, would be $689 plus that simple interest principal, which is $19.50, which would give me $708.50. And the fifth term, right, would be the $708.50 plus the $19.50, which would give you $728. Remember, in simple interest, you're always taking the percentage of the original principal and adding that each year. All right. So if $650 is invested in an account at 3% simple interest, write the explicit formula, right, representing the account balance in any given year. Use this formula to find the 25th year. Well, we know A sub n equals your original principal, right, plus n minus 1 times your interest rate times your principal. So in this case, A sub n is you're starting with 650 plus what is your rate times your principal? We said that was $19.50 over here times n minus 1. And if we want to find 25 years, A sub 25, 650 plus 1950 times 25 minus 1 is 24. And if you evaluate that, you would get $1,118. Okay. Number 7 and 8. Number 7, you invest $2,500 in an account earning 3.5% compounded annually. You don't make any other deposits or withdraw until the 9th year. When you withdraw all of the money in the account, how much do you receive? Well, if we start with our explicit, it would be A sub n equals, right, your 2,500 times 1 plus your rate, which would be 0.035 as a decimal, to the n minus 1. So now when we go to find out how much is in it after 9 years, A sub 9 is 2,500 times 1.035 to the 8th power, and A sub 9 equals 2,500 times 1.035 to the 8th ends up being $3,292.02. Okay. The next one, a petri dish contains 7 bacteria. Each bacterium produces by splitting in half, which means it's doubling each time, right? If it's splitting in half, that means it's doubling, right? How many bacteria are in the 6th generation? So A sub n equals, you're starting with 7, right? And if you're doubling each time, your rate is 2 to the n minus 1. Remember, it's containing 7 bacteria. That's your initial amount. So A sub 6, right? So 6th generation would be 7 times 2 to the 6 minus 1, which is 7 times 2 to the 5th, right? And 7 times 2 to the 5th would give you 224. All right. So for 9 through 10, solve the problem using Fibonacci and pyramidal. All right. So the 8th term in the Fibonacci sequence is 21. The 10th term is 55. What is the 9th term? So if you know you have the 8th term, remember, you go from 8 to 10 to 9. And remember, the 8th term plus the 9th term has to equal the 10th term. So what was the 8th term? 21. Plus, what is the 9th term? I don't know that. And what was the 10th term? 55. And if I subtract 21, right, your 9th term would be, that's 21, would be 34. Okay. Now the recursive formula for a pyramidal sequence is P of n equals P of n minus 1 plus n squared. A stack of cannonballs with 7 layers has 140 balls. A stack with 8 layers has 140 plus 8 squared, or 204 balls. Find the number of cannonballs in a stack that has 10 layers. Right away here, right, you know P of 8 is equal to 204. You know P of 9 now would be whatever P of 8 is plus 9 squared. And what is P of 8? 204. And what is 204 plus 81? That is 285. So now to find P of 10, right, I need P of 9 plus 10 squared. Well, what was P of 9? P of 9 is 285 plus 100. Therefore, P of 10 is going to be 385 cannonballs in the 10th layer. Okay, go ahead and try the quiz now and let me know if you have any questions.